Hi everyone and welcome to today's lesson. We are still busy with present value annuities, but in today's lesson we are going to learn how to calculate n, which is this exponent right here. If we are given the present value, we're given the equal payments, we're given the interest rate, and we also know the compound periods. So to do this and to calculate an exponent that is a variable, we are going to use a logarithm. So pay attention, and the easiest way to demonstrate it is with an example. So Jacob buys new machinery to the value of 450,000 Rand. So that's the purchase price of the machinery, in other words that's P. He borrows the money from a financial institution that charges 15% per annum compounded monthly. So our interest rate is 15%, so I is 0.15. The compound periods is monthly, so that is 12, and he agrees to pay monthly installments of 8,000 Rand. So the monthly payments is equal to 8,000 Rand, that is X. How many months will it take for Jacob to pay back the loan? So we're going to write down our present value annuity formula, because this is a down payment on amount of money that we owed. So basically here is the formula, and we are going to put everything in its place as normal. So the present value of the machinery is 450,000. Our payment that we are going to make, our X, is 8,000 Rand, so that goes into X's place. 1 minus 1 plus, in the place of I we're going to put the 15% as a decimal, 0.15. The compound periods is compounded monthly, so that is 12, and we leave the minus n because we don't know for how many years we're paying it. So basically we cannot figure out how many payments all in all, since we only know the compound periods. And then we're going to put I again at the bottom, so 0.15, and the compound periods, which is 12. And now what we do is, since we are dividing with this value, we are going to multiply with this 0.15 divided by 12 on this side. And once we finish that multiplication, we're going to divide with the 8,000 because we're multiplying here. Okay, got it? So we're going to multiply with this value on this side, and we're going to divide with the 8,000 on this side. And once we do all of that, we can simply just do it on the calculator. We end up with 0.703125 is equal to, and remember now this 8,000 and that 0.15 divided by 12 is gone, so we are left with 1 minus, and then this is also only numbers, so we can simply do this math, 1 plus 0.15 divided by 12, and we have 1,0125 in brackets to the power of minus n. Okay, so far so good. Then this constant, which is a positive 1, goes to the other side and becomes a minus 1, and 0.703125 minus 1 gives us a negative 0.296875. Now please do not round off, since we're busy with money and values. We can only round off our final answer, and that is equal to negative, in brackets, 1,0125 to the power of minus n. So now this negative and negative we can basically divide or multiply with the negative all the way through, because this is a equation, and then we have 0.296875 is equal to 1,0125 in brackets to the power of negative n. Now here is where the logarithm comes in, because we want this variable and the n is an exponent. So basically what we do is we write down the log, and the base of this exponent, this 1,0125 is the base, becomes the base of the log. That's quite easy, and that what this part is equal to. So this 0.296875 gets written in front of the log, and there we go. So it's really that simple, and that is equal to this negative n. There we go. So once we do this problem on our calculator, we just use our calculator to type in log, or we use the log function. The base is 1,0125, and in brackets there we put 0,296875. Once we press equal, you will see that it's minus 97,76 is equal to minus n. Again, because this is an equation, we can multiply with the minus all the way through, so 97,76 is equal to n. Now, what does this 97,76 basically mean? Well, there were 97 equal payments, but then we also had to make another payment that is worth 0,76. Now, we cannot simply just say it's 0,76 of our normal equal payments because it also contains interest. But what we do know is that there is another payment that is not a full payment. So how many payments, how many months will it take Jacob to pay back the loan, or how many payments? There are 98 payments. Got it? So we got 98 payments were made, so 98 months that we had to pay off this loan, where there are 97 equal payments and one last payment that's a little bit less than the usual amount, because you can see there's 97 equal ones and then a 0,76 of a payment. Got it? So 98 payments where 97 is equal payments and then one more payment. Let's go look at another example, because we now want to know how much will that last installment be. Now in this part of the video, we are going to calculate the last installment. Now what we do is we simply write down our normal present value annuity formula, right? And we know that there were 8,000 equal payments and that there were 97 of those equal payments. But we know we made 98 payments as we calculated it earlier. So the last payment, we're going to add the last payment, and that last payment's part we can write it as K, which is our last payment, but that payment has to carry 98 months worth of interest. So we're going to multiply it with 1 plus 0,15 over 12, right, to the power of minus 98, because this is the 98th payment. So basically, we have all our values in our present value formula. So there's our 8,000 equal payments for 97 months, and this is our 98th payment. Now we just simply want to solve for K. We can simply type all of this into our calculator as this part of the formula is complete, and we end up with 448,194 Rand, 1358. And again, do not round off in the sum because we're busy with money and we can only round off our final answer. So plus K in brackets 1,0125 to the power of minus 98, because 1 plus 0,15 divided by 12 is this. So now we can take this constant to the other side. It becomes a minus 448,194 Rand, 1358. And once we subtract those two, we end up with 1,805,864191. Again, do not round off, is equal to K in brackets 1,0125 to the power of minus 98. Then to have the K alone on this side, we're going to treat this as the coefficient. So we take it just like that and divide with it on the left side. So once we divide, we get the value of K, which is 6,100 Rand and 96 cents. So that is our final payment. So again, I'm just going to write it out. The last payment will be 6,100 Rand and 96 cents. So please remember this formula. It's really important, and this whole entire video is quite important to know how many equal payments there are, is there a last payment, and how to calculate it. Bye.